coordination via selling information. Let's code the welfare. Let's plot welfare next to revenue. Let's finish this. Let's get some intuition. Let's share our paper with the world. So welfare is quite similar to revenue, if you remember. Right? It's quite similar. So in welfare, in revenue, we had this cubic equation. Where is it? Cubic function that we cut with the ellipse, the sigma I theta I and sigma I omega over in this curve, and intersection of the ellipse and the cubic curve. Now they are actually for welfare on a simpler curve. We already have the formula. We do not need to solve anything. So let's do it. So where is welfare? Where is welfare? Okay, welfare maximization. By the way, we need to take care of delta and our elliptic equation. Okay. This is our ellipse. Second one is binding all the time. And we know that this is it. Sigma I omega over S sigma omega square is lambda NF plus 1 over 2 and lambda F minus R. Sigma I theta I over T sigma theta I squared is lambda NF, that big ratio. So welfare optimal mechanism with the largest revenue. Match the XI coefficient. So now we install import numpy as np, imply plot for plotting, ns, these are variables, em hyperbolic, because now we have just, let's check this. Can I put them in two different? So x is sigma ai theta I over t sigma theta I squared, so it is lambda nf, right? Lambda nf r squared plus 2f minus r1 plus r, or is that plus 2f minus r times, times 1 plus r, and then minus 2 plus r times r minus 2 plus r times r over 2 1 plus r lambda nf f minus r. So it is similar to the nominator. Okay. Lambda nf f minus r minus 1 plus r times r. Anyways, and then that's it. Y is sigma over s sigma omega squared. It is 1 over 2n exactly times lambda nf plus 1 over lambda f minus r minus r. Perfect. What about the mean? We don't want the mean. How in we do want the mean? Why? Yeah, we do want the mean. If we need it in revenue, we will need it in we need it in, even if it is obedient mechanism, we need mean, but we are just returning it. Okay, The thing was that we don't need the mean here actually. I thought we are returning mean as a output of the function, but no, just we need the mean in optimal revenue to compute the x and y. So we don't need it here. Alright, even simpler. And then we have the elliptic equation, which is this. I wish I knew. So let's check what is the relationship between this one and this one. Pretty the same shit. Yes. L is lambda. Let's call it what it is. And mean A, we know what it is. Sigma IAJ. Is it for R negative only? Yeah. And lambda is okay. Now the other change is that lambda is the solution. This. Okay, this equation, where is it coming from? Is coming from substituting x and y in the equation we have from elliptic. So we don't need to solve this equation, degree 4 equation. We can just use the same method, intersect our hyperbolic curve with the elliptic curve. Pretty the same shit. Nu is positive, so the second one is binding. Let's go. We are going to do a bisection method to find the lambda. Not, I should change it to hyperbolic, right? What was A? Okay. A is the start of the interval, B is the end of the interval. So hyperbolic. And so what we do, we start from A0, and if it is outside, if ellipse is positive, it means B should be always negative, and then x and y is hyperbolic again. So if lambda 0 does not work, right? While ellipse of x and y and r, ellipse is positive, right? So while it means B is inside. What is x and y? Greater than 0? Okay, now it means that still even B, which is the end of the interval, is not inside the ellipse, and for that we need to increase B. So we are doubling B, and then we compute x and y and go until up to the point that B finally gets inside the ellipse. Now we are in a situation that for A0 we are outside the ellipse on this hyperbolic curve. A is outside, B is inside, and this curve comes and cuts the ellipse. By the way, when yeah, okay, that we don't need. Ellipse is less than 0. So now what is this ellipse? Is less than 0. Is x of and y of B. So we are inside the ellipse, and while B and A are not close enough, we wanna find the middle of the interval, right? Then compute the hyperbolic function for this midpoint, and compute the, if k is, so we compute it, if c falls inside the ellipse, we need to get c and a. If c is outside the ellipse, we need to get c and b. So less than, yes, exactly. Break. And what is yy? Well, okay. And c will be lambda. Wait, why should it be 0? When is delta 0 here? So when did we have delta? Okay, we have delta when we have an interior point solution, right? When our starting point, when lambda is 0 actually, when lambda is 0, we are inside the ellipse already, and then we can have it extra noise so that we are in a ball that is like a tangent inside the ellipse that is tangent to its borders. So when a is not 0, when lambda is not 0, definitely the delta will be 0. Exactly. And this is the value for sigma aj. Else we are an interior point, and what is it? Now x is x and y and r. So this else is to this if, which is if a, x and y generated from 0 is not positive. It's either 0, it's or negative. We are inside, and xc is not minus ellipse. What is the ratio? You tell me. You tell me what that means. Else xc is this shit. Is it the same for welfare and revenue? The ellipse formula for both are the same. Exactly. Yeah, the delta formula should not change. Xc formula should change. And is it the same as yes, if this ellipse and that ellipse are the same, it means that this xc and that xc should be the same, which are okay, perfect. And then we have our delta. This lambda c is 0. Well, what is c? C is 0. Here. No, we should say 0. Why does it have? So it seems our revenue code still has problems. This formula doesn't change, this formula doesn't change. Okay. Here we can see that A is already positive, so we don't need interior point. Shed. Exactly. But let me change the code. When R is negative, we can have interior point. But when R is positive, it's impossible to have. Perfect. And cubic is not defined. Where is cubic? Okay, I think it's just there. Okay, by the way, what is payment? We want the optimal welfare that leads to, among all the optimal welfare functions, we want the one that maximizes payment or revenue. So let's see what payment should be. Max payment slash revenue optimal welfare mechanism. Right? And we want to say so the derivative of payment stays the same. So where do we have this formula from? The derivative of payment, so this is the formula when we have the optimal revenue, right? So here we have it. So now, okay, let's open this. Does it say that actually for optimal welfare we have the same thing? This term. If it is, it's really good. $3.14. Be a Gaussian mechanism rule satisfying the covariance condition. Okay, we need to check if it is satisfying this. Or actually x greater than 1. If x is greater than 1 all the time, then the maximum expected payment collected from player I while incentivizing truth telling and participation is this. Okay, the thing is that when we are optimizing welfare, we don't care about the extra terms because the objective is just expected of you. Here we just need to compute payment based on this formula. That was why computing expected maximum revenue problem was a bit more difficult. We had a ratio or like hyperbolic function 1 over x in the objective function. But for optimal welfare, we don't have it. So that's it. Actually, we have corollary of 3.14. Expected of pi theta I equals expected of ui minus t sigma ai theta I over 2 minus t mu ai squared sigma theta I squared over 2 sigma ai theta I, and expected of ui is in optimal welfare not revenue but welfare. In optimal welfare, fucker, where are you? Okay, it is it. Perfect. And expected of ui is mu ai squared plus sigma ai squared over 2 minus t sigma ai theta I over 2 minus t mu ai squared sigma theta I squared 2 sigma ai theta I. Perfect. And now I want to change the payment formula here, which is mean A squared, which we have it here, over 2. Very good. What is the formula for sigma AI squared? That's the only thing I need to know. Then we have minus t over 2 times sigma AI theta I, which is xx times t sigma theta I var theta, exactly, minus mean A squared over 2 over x. Perfect. And so we are saying that it is the formula for sigma AI squared over 2. So this should be minus 1 AJ. Is that it? It should come from obedience, I guess. N minus 1 R sigma AJ is sigma I omega plus T sigma I theta I. Let's see. Yes, that's it. Sounds right. Right. Sounds right. Damn right. Damn right. That's right. Sounds right. Okay. What is wrong? Float object is not callable. Yes. Why don't we have the same problem here? Oh, I cannot run here. What is he saying? Same shit. What's wrong? Are we, okay. Probably there is a. Okay, good to know. Which formula is it? X and Y, and then we have X, ln times F. Perfect. found it in a second, thanks to AI, thanks to ChatGPT, thanks to ourselves. We are the people who built ChatGPT. Perfect. What is wrong? Okay, line 94. I thought we changed all of them. Oh, there is one more here. There is one more here. Oh, okay, we just changed it for negative values of R. Negative, negative. Cubic. Perfect. So now what do we want to do? Yeah, we now want to plot some shit. So data set 1 is 3 and everything 1. And data set 2. So what is 100? Sigma omega squared or something. And this is 10,000. And let's plot now. It's quite similar, right? It's pretty similar. Actually, it is very nice to see the difference in revenue and welfare. Perfect. Oh shoot, okay. Almost the same thing. Oh, delta changed. Feel the same still. Feels. And what else? Payment. Quite similar, right? That's actually good. Like, who cares about? It shows that welfare and revenue are pretty much the same shit. Oh fuck. Yeah, I remember this is also similar. That's good. Okay, fuck welfare. Now let's go to the next benchmark, which is Bayes Nash or Nash equilibrium. Complete information Nash. Just make sure. Okay, the optimization problem stays the same, by the way. If you remember, the optimization problem does not change for mean A. So, for the fraction rate, Frank fraction term. Is it the last plot? Yeah. So it doesn't change much, to be honest. Good to know. Good to know that it doesn't change. What about payment? We didn't draw payment, or we did? Yeah, we did. Yeah, payment, I remember it was pretty much the same shit. Yeah, it was like that. Okay, let's see. Nash equilibrium. By the way, is our x is always greater than 1? Sigma I theta I, right? Where is it? Oh, okay. Honestly, I don't know if it is. Mm. Okay. So what is the size of it? Uh, where is it? So there are some values. Sorry, what did I do? What is this? Okay, they are always greater than 1. Perfect. Okay, what is Nash equilibrium now? Oh. Nash, and we want to have base Nash, right? Complete information Nash. Now let's find base Nash. Okay, the thing with Nash is that in the complete information Nash equilibrium, they know omega and theta I and everything. So is there any point? Is there any point? There is no sigma AI theta I. Because sigma AI theta I should be 0, because omega theta I, sigma theta I squared is 0, sigma theta j squared, sigma omega squared is 0. It doesn't mean anything to have sigma AI theta I. Okay, you may say this is the recommendation formula, but I'm curious to know the Bayes Nash. I think Bayes Nash is here. Okay, not the Nash complete information Nash, but what if the mechanism that the platform promises and commits to it gives the same action recommendation? Is this mechanism truthful? Is this mechanism obedient? Is this mechanism individually rational? It should be. In 4 is 4, this is also an obedient mechanism. Oh, Bayes Nash is also here. Alright, perfect. 3.5. Where is 3.1? Oh, proposition. Yeah, that's it. Mechanism being obedient. Yeah, sigma j is 0, sigma theta j, which is means x is 1. Perfect. We can plug both of them. Alright. Yeah, we can do that. Okay, we did the difficult ones now. Now these two are pretty easy. Yeah, they're fucking easy. Yeah, let's finish this then. Let's play some Counter Strike. Fuck off! Okay, get back to the... So what is it? Nash equilibrium. Complete information Nash equilibrium. Sign. Perfect. Okay, I need to take a pause. Happened to me. Oh, okay, I'm back. I'm back. I am back. So, uh-huh. So mu AI will be the same shit. So we will delete a lot of shit here. All right. I wanna keep these. No ellipse. No. I don't know why should you have that. Uh, there is no intersection game. So new AI obedience says Perfect. So sigma AI sigma AI squared AI theta I, we have them. We want sigma AI omega, we want sigma AI AJ. Fuck AI AJ, AI AJ is a mess. Okay, I will tell you what we are going to find from this formula. We want sigma AI theta I, sigma AI omega, and sigma AI theta j. Alright, once I have these, I can find sigma AI squared and sigma AI AJ. Just to make sure, is it the way we do it in the code? X, Y, then we have sigma AI AJ. But sigma AI theta j, we never computed it, and sigma AI we never computed that too. Doesn't matter. Okay, let's get back to this. So sigma I can compute all of them, don't worry. Sigma AI theta I. So I, what is sigma AI theta I? Is expectation of AI minus mu AI times theta I minus mu theta I, right? Which will be perfect, exactly. S over S over 1 minus n minus 1 r sigma okay, omega and theta I are independent, so 0. First term 0. T theta I and theta I are not independent, which causes us T sigma theta I squared over 1 minus n minus 1 r plus RT 1 plus r 1 minus n minus 1 r sigma theta j theta I are 0. We have a minus sign. Theta I which is sigma theta I squared, right? So it will be n minus 1 squared, which will be t sigma theta I squared 1 plus r 1 minus n minus 1 r r 1 plus r minus 1 plus r minus r times n minus t sigma theta I squared 1 plus r 1 minus n minus 1 r is it right? Sounds right. T sigma theta I squared 1 minus n minus 2 r. That's what it says. One last time. 1 plus r. So we have t sigma theta I over 1 minus n minus 1 r in common, and then we have 1 plus r minus n minus 1 r, which is 1 minus n minus 2 r. Exactly, that's it. So let's go xx again. X will be sigma ai theta I over t sigma theta I squared will be 1 minus n minus 2 r over 1 plus r 1 minus n minus 1 r. Is x greater than 1 now? It's the question. Is greater than 1. We know that r is minus 1 and 1 over n minus 1. So 1 plus r is positive. 1 minus n minus 1 r is positive. And 1 minus n minus 2 r is greater than r. That is not obvious. Is it positive? Okay, I don't care. Let's check. So we can say this comes here to 1 minus n minus 2 r equal 1 plus r 1 minus n minus 1 r and 1 minus n minus 2 r 1 minus n minus 1 r plus r minus n minus 1 r squared so these two cancel out and this term, and we are asking if 0 greater than minus n minus 1 r squared, which is always the case. So x is always greater than 1, good. So we have our IR satisfied. Okay, we need a function that gives us x. X equals 1 minus n minus 2 times r over 1 plus r times 1 minus n minus 1 times r, right? And that's it. X is this. What is y? It should be even easier. Sigma ai omega is theta I and theta j are independent of omega, so it's S sigma omega squared over 1 minus n minus 1 r. Therefore y will be 1 over 1 minus n minus 1 r. Dude, if it is easy, just finish it. Yeah, dude, why are we wasting our time? Just we need to some value sigma. Okay, x, y, what is the next one? We can compute sigma ai squared or sigma aj, which we should multiply these big terms together. Instead, I like to compute sigma ai theta j. Oh, you're seeing nothing, right? Okay. Sigma ai theta j. Just one of them, right? So theta j and omega theta I are 0, so it will be RT 1 plus R 1 minus n minus 1 R, right? RT 1 plus theta j, we have theta j and theta j. Sigma theta j is squared, which is sigma theta I squared. RT 1 plus R So that's it, and sigma I theta j will be r times 2 times r theta r times theta times var theta over 1 plus r over 1 minus n minus 1 r. Perfect, right? RT var theta 1. And then we want to have AI squared and sigma sigma I don't know if we need them. Fuck that. I don't want to write them. Just sigma aj is, because we are plotting it for other people, sigma aj is fuck. Okay. The thing is, sigma I theta j and sigma I theta I are close to each other, and for computing sigma I squared or sigma I aj, we need to compute one of those. So we don't need the sigma I theta j. Let's see where that formula comes from, sigma I theta j. Is sigma aj in welfare and revenue the same thing? Or is it? Oh, it comes from elliptic equation. That's why we don't have it here. Second elliptic gives us sigma aj exactly. So here we don't have it sigma aj, but we can compute it. Yeah, let's do it once. So again we have this. Copy. And sigma ai aj will be so aj is actually that's for example k, actually theta I minus theta j, right? So sigma ai aj will be s squared sigma omega squared over, like, omega of aj is only covered by the omega of ai, no other interesting part, right? S sigma omega, s squared sigma omega squared over 1 minus n minus 1 r squared. And then what is from ai? Theta I. That theta I has 1 theta I in the sigma, so it has plus TRT RT squared sigma theta I squared over 1 plus r 1 minus n minus 1 r squared. Then what? These theta j's, one of them has with the aj plus, similarly rt sigma theta j squared, which is theta I squared over 1 plus r 1 minus n minus 1 r squared. And we also have a theta I here minus, oh, we have a lot of them, which are multiplying only by one of them, plus minus n minus 1 rt, right? Minus n minus 1 rt over 1 plus r minus n minus 1 rt over 1 plus r 1 minus n minus 1 r times rt only one of them, 1 plus r 1 minus r I squared. Am I right? So omega is just the first term, so perfect. Theta I, not with omega, not with theta j, with the other theta I here, which is perfect. Theta j, with the theta j, which causes rt squared rt squared minus okay, and then theta j with all those theta j's in the sigma, 1 from ai and n minus 1 from aj, so it will be r, oh, it's here minus, sign minus, so it will be minus r squared t squared n minus 1 plus r squared, exactly. And we have minus n minus 1 theta I, which here, so I made a mistake. It's one of them. Where does this third term comes from? second term is right. Third term, first term is right. Second term is right. Third term is again second term, which should not be. Let me clean this shit. But the fourth term is right. Now it's third term. So fourth term is coming from theta j from AI, which is only 1, in theta j in AJ, which is 1 here and n minus 1 in the sigma. So, right? So it will be RT RT over 1 plus R 1 minus T okay, this is not okay. I got headache, guys. I'm dying. Yes. Oh, it gave me headache. Fucking shit. It's really good. Let's finish this. Let's finish this shit. I don't wanna ruin my energy again, my good energy again for some bullshit. So I think I need to clean this. Why did I do that? No, I don't need to clean this. Keep it. S omega to omega. S squared sigma omega. This is it. The next one is t theta I, which results to this second term. We all agreed. RT squared, perfect. Then we have the theta j, 1 theta j in the sigma from AI to all of this fucking theta j's in the AJ, which first term results in a similar term which we previously deleted it, so now it makes sense why it was here. Now this theta j comes and makes the second term again here, another time here, copy, paste, right? And this theta j is being multiplied by this exactly, but when it multiplies by the all n minus 1 theta j in the sigma, we will have minus 1 n minus r t squared 1 plus r exactly. Now we have the minus n minus 1 theta I inside the AI to the theta I 1 theta I we have inside the AJ, which will be plus minus n minus 1 RT, right, over 1 plus R 1 minus n minus 1 R times what? Only 1 theta I RT 1 plus R 1 minus n minus 1 R theta I squared. Okay, so this term should be computed twice. Sounds good, right? So we will have sigma AI AJ. Honestly, I don't think we need it, but This is squared sigma omega squared over 1 minus e minus 1 r squared plus 2 RT squared sigma theta I squared 1 plus r I can do that. I can make it simpler. Will be s squared sigma omega squared 1 minus r squared plus something. Okay, yeah, plus this 1 plus r squared r squared fucking 2 t squared Now what is it left? 2RT. We have 2RT squared sigma theta. We have 1 plus r, right? Minus, we have n minus 1 here, r here, 2RT is switching. Perfect. So it will be actually, this is 1 minus n minus 2r. S squared times var omega over 1 minus n minus 1 r power of 2 plus 2 times r times t squared var theta times 1 minus n minus 2 times r over 1 plus r squared over 1 minus n minus 1 r and then started raining. How can I concatenate two NP arrays? np.append. Oh, it was right here. What else, guys? Just we need to. Why should we compute sigma I theta j? Oh my god. That's it. That's right. That's it. That's right. Baby, no money. Okay. Sigma IAJ. We have sigma IAJ, XX, YY. What else do I want? Mean A. We already have it. Is the formula for payment changing? Hand hurts. Payment. Let's go for payment. It was here, right? Expected payment. Well, the truth is that expected payment won't be very different. Truthful, very truthful. So we are not doing, when we are saying complete information Nash equilibrium, when we know that the action recommendation, once we say that, we are assuming that it's not complete information Nash. Platform recommends this action recommendation. Is it obedient? Yes. Is it truthful? we need to see if x is greater than 1, which is, and we need to have sigma I theta I. Okay, so the formula for payment again comes from this shit, and so guys, I have headache. Okay, motherfucker, what is the expected of UI? It's here. Is it expected of AI? Okay. Okay guys, I'm done. Honestly, headache. Tomorrow. Let's play some Counter-Strike. Did you see Messi's ankle last night? By the way, Argentina sucked. They were not good at their game. Argentina sucked. Messi barely played anything. I don't know why he cried. He had every fucking cup. His ankle was huge. Both teams sucked. The whole from now on, any national competition sucks. I'm so glad I didn't watch fucking Spain and England.
Let's roll.
Oh, 15 minutes. Well, we know we have 3 games, like 2.5. Fuck that. What do you say? Oh. It felt like it. Oof. That was nice. Oof. That was nice. Dude! It was my fault. One. Two people people at the time. What am I doing? Don't kill me, don't kill me, don't kill me. I always feel they don't give this. Oh shit! It just doesn't work from this distance. That's it. That's me. That's me. Who killed me? Sorry.
Doors. Are you streaming?
Yes.
Okay.
It's okay. It's fine.
Okay, alright.
Yeah. Sorry. If I make noise, let
No
me
worries.
know.
I have headphones.
Guys, honestly, I went to failure. That was it. I didn't have any brain cell left for that computation. But like when I was playing the game, it was completely fine. I don't talk much.